All right, ladies and gentlemen, our objective today is to factor the difference of two squares. Let's take a look at the words here because this phrase, difference of two squares, is important to understand. What does the word difference mean? Well, hopefully you thought of the operation minus. What about squares? What are squares? Well, let's take a look at that because that'll be interesting and important to know. What are squares? For our purposes here, we're going to consider squares to be one of the following. It could be a perfect square, a variable with an even exponent, or the product of any combination of number 1 and number 2, these two right up here above. So let's start with perfect squares. Ladies and gentlemen, I want you to take a moment, see if you can list out the first 5 perfect squares. You should know this. Okay, when I give you a moment, do pause the video, give that a try, please. So, perfect squares, hopefully you wrote out 1 squared, which is 1, 2 squared, which is 4, 3 squared, 9, 4 squared, 16, 5 squared, 25, etc. These numbers, and the list continues on forever, these numbers here are our perfect squares. And of course, the way we get them, oops, sorry about that. Oops, there we go. All right, the way we get them, of course, is we take our counting numbers and we just square those. So, for instance, we could take the number 1, squared, that gives us 1, 2 squared, that gives us 4, 3 squared, 4 squared, etc. Let's take a look at the next possibility. The next possibility for a square is going to be any variable with an even exponent. So let's choose a variable of x. And let's give it an even exponent. We know even numbers are 0, 2, 4, 6, 8, 10. Let's just start with 2. Another possibility, y to the 4th power. Another possibility, w to the 6th power. Okay, so these are some examples of perfect squares. Number 3 is the product of any combination of 1 and 2 above. What does the word product mean? Well, hopefully you thought of multiplying. Put a multiplication dot there. So basically what we can do here is we can choose any red number. I'm going to choose 25. And we can choose any variable with an even exponent. I'm going to choose x squared. And we'll consider that also to be a square. So I just chose 1 from here, 1 from here, and then I multiplied those together. Another possibility, choose 1 from here, 49. Doesn't matter which number you choose, of course. And w to the 6th. All right. So that's what we have with squares. Now, this pattern from now on, difference of 2 squares, I'm going to call dots. Where the letters dots come from difference of 2 squares, D-O-T-S. That's where the letters come from. And the question that you may have is, why are we studying this particular factoring pattern? Well, it turns out that this pattern reveals conjugate multiplication. Abbreviate there, it reveals conjugate multiplication. And conjugate multiplication is going to be something that you're going to use a lot of in higher level math. And so this may not mean that much to you now, later it will. So let's take a look at an example of the main pattern. What I want to have you do is I want to have you take a moment and multiply this out. So pause it, give that a try. Okay. Hopefully when you multiplied this out, and it doesn't matter how you multiply this out, I know there are many ways to do it. You could use the box method. You could use the FOIL method. They're all the same thing, the distributive property. We're going to end up here getting x squared minus 5x plus 5x minus 25. Now, of course, typically we're going to combine together any like terms to simplify, to clean this up. We're going to get x squared. These drop out, and we're left with minus 25. This type of a pattern right here, used backwards, if we reverse this, is going to be our dots factoring pattern. So let's reverse this problem. Instead of starting with this, we're going to start with the answer. X squared minus 25. And what we're going to do is we're going to end with this. X plus 5, X minus 5. There we go. And now, as long as we reverse this pattern, we're going to end up taking this and factoring it into that. Now, let's take a look at our problem here very briefly. As we take a look at the x squared, we're going to get an x and an x right here. 25 is going to basically give us the 5 and the 5 right here. In fact, the way I teach it to students to make it very quick is this. I say, take the square root of this term, the positive square root. And if you take the square root of x squared, you're going to get x. Take the square root of 25. Ignore the minus sign. Square root of 25 is going to be 5. And then what do? We're going to take the x and the 5 and we copy them down. x5, x5. And our signs will always, for conjugates, for this kind of a pattern, be a plus and a minus. Always. And that's it. Let's take a look now at some practice. You may already know how to do this. Hopefully this gives you, maybe this was just a good review for you. I want you to try number 1. So pause it, give that a try. All right, let's go through problem number 1 together. To factor it the way I showed you, basically we're going to take the square roots of each one of these terms right here. Obviously, square root of x squared is going to be x. Square root of 16 is going to end up being 4. And now we can write out our answer. We're going to use an x plus 4 and an x minus 4 in our 2 pairs of parentheses. So x plus 4 and x minus 4. By the way, you could, of course, have these 2 quantities switched. So your answer could be x minus 4 times x plus 4. You probably have learned that these are the same thing. So either answer is fine. I want you to try number 2 similarly. So pause it. Okay, let's take a look at number 2. Square root of y squared is y. Square root of 49 is 7. So we're going to go ahead and use the y and the 7. First with a plus here, because I'll usually put the plus first. And then with a minus here, y minus 7. Okay, ladies and gentlemen, just a quick review right here. In something like this, what does the number y represent? Hopefully you remember that the number y could be any number. I'll use that right there, any number. In a polynomial expression like this, y can be any number. So let's go ahead and make sure that this is correct by trying a few numbers here. This won't guarantee that it's correct, but this will demonstrate something that maybe you haven't seen before. We took y squared minus 49. And we factored it down into y plus 7 times y minus 7. Now, let's choose a number for y. You can choose whatever number you want. Doesn't matter. What I'm going to do is I'm going to go ahead and choose the number 8. But like I said, you can choose y to be whatever you want it to be. Let's take the number 8 and plug it in right here and see what happens. Well, we're going to get 8 squared, which is 64 minus 49. Well, what's 64 minus 49? That gives us a 15. So the top number there is a 15. Let's plug in the 8 here as well, because we know if y is 8 right here, all the other y's have turned into 8s as well. 8 plus 7 gives us 15. And 8 minus 7 gives us 1. It's 15 times 1 give us 15, you bet. And you can try this with any number you want, and it'll always work. Isn't that neat? Okay, ladies and gentlemen, let's go ahead and try number 3. I want you to try that on your own here. Okay, hopefully at this point, you're getting these done fairly quickly, and you get an answer of c plus 10. and c minus 10. I want you to go ahead and try number 4. Be careful. It's a trick question. Okay. Hopefully, one thing that you realize right here is number 4 is very different from problems 1, 2, and 3. In problem number 4, we have a plus sign. And if we have a plus sign right here, it actually is not difference of two squares. This is not dots. So this problem right here is not difference of two squares because the plus sign ruins it. Why is it ruined? Well, difference means that we need to have a minus sign right here in the middle. So it's got to be a minus in the middle, or we need to be able to rewrite it with a minus in the middle. And this right here being some sort of a number or a square. And because we can't write it right here, this one right here is not factorable. And like anything that's not factorable, we can call it prime. This is like a prime number. You can't break this down. All right, I want you to go ahead and give number 5 a try. This one a little bit unusual. Okay, let's take a look at number 5. Hopefully you got the quantity 2x plus 3 times the quantity 2x minus 3. Let's take a look. Here we have 4x squared minus 9. Is this the difference of two squares? Well, we have a minus, so it's difference. And both of these are squares, aren't they? So let's do our square roots. Square root of 4 is 2. Square root of x squared is x. Square root of 9 is 3, right? How do we know this is right? 2 times 2 is 4, right? X times x is x squared. 3 times 3 is 9, right? So let's go ahead and write out the final answer here. Once with a plus and then with a minus. So we get 2x plus 3 times 2x minus 3. And again, what number is x? Hopefully you said any number. All right, why don't you try number 6 similarly? Okay, let's take a look at problem number 6. Hopefully you got the quantity 3m minus 1 times the quantity 3m plus 1. Let's go ahead and go through that. So we have, again, the difference. It's got to be a minus in the middle. And here we do have that. So let's take our square roots. Square root of 9 is 3. Square root of m squared is m. And square root of 1 is 1. So writing out our answer here, it'll be 3m plus 1, 3m minus 1. Just like that. All right, ladies and gentlemen, let's go ahead and plug in a number for m here. What number should we plug in? Any number you want. That's the great thing here. So what we have right here in this problem is we've got 9m squared minus 1. And so I'm going to go ahead and write that here, 9m squared minus 1. And that's going to factor into 3m plus 1 times 3m minus 1. Now, again, let's go ahead and choose a number. And I'm going to go ahead and choose a number not too big. I'm going to choose m equals 2. But again, you can choose whatever number you want. Let's plug in 2 right here for this m, that m, and that m, and see what we get. Well, if we plug in 2, 2 squared is 4. 4 times 9 is 36. 36 minus 1 is 35. So the top is 35. Let's replace this m with a 2. 3 times 2 is 6. 6 plus 1 is 7. Let's replace this m with a 2 as well. 3 times 2 is 6. Minus 1 is 5. Does 7 times 5 give us 35? You bet. All right, let's go ahead and move on. I want you to try number 7 and number 8. So pause it, give those a try. Okay, ladies and gentlemen, let's go ahead and take a look at number 7. For number 7, we've got 2 variables. What are these values here? Any number you want them to be. And if we take the square roots, we're going to get square root of m squared, of course, is m. Square root of n squared is n. So we're going to get a plus first and then a minus. M plus n, m minus n. After a while, ladies and gentlemen, you don't even need to write this out. Hopefully you're able to just write out your final answer. Let's take a look at problem number 8, the last one. In problem number 8, we can take the square root of this term right here. 25 gives us 5. Square root of p squared is p. Square root of 4 is 2. Square root of q squared is q. So once with the plus, then with the minus. So 5p plus 2q. And 5p minus 2q. Okay, ladies and gentlemen, hopefully that helps out with difference of two squares. By the way, one thing I wanted to mention. If we write out the word difference, this word is very similar to the word different. And when you write out your answer, notice this. These two signs right here will always be different. Always. That may help you. Okay, ladies and gentlemen, good luck with your math.